Welcome everyone. I'm excited to welcome you to today's training session. Today, we'll be focusing on safety training for industrial personnel, specifically on fire prevention for chemicals. Our main focus will be on calcium hypochlorite. Over the course of this presentation, we'll cover key safety practices, potential hazards, and prevention strategies to keep everyone safe. Let's get started. Today, I want to introduce you to calcium hypochlorite, which is often represented by the chemical formula Ca, ClO2. This compound is widely used as a disinfectant, a bleaching agent, and in water treatment processes. Its primary role is to help purify water and eliminate harmful bacteria and pathogens. One of the key characteristics of calcium hypochlorite is that it's a strong oxidizer. This means it reacts readily with organic materials, breaking down contaminants effectively. That's why it's so valuable in sanitation and disinfection applications. You'll usually find calcium hypochlorite in the form of a white or gray powder, or sometimes as tablets. Its physical form makes it easy to handle and dose in various water treatment settings. Overall, calcium hypochlorite is an essential chemical in maintaining safe and clean water, thanks to its powerful oxidative properties and versatility in different forms. Let's take a closer look at some key safety information. The UN number for this substance is 2880, which helps in identifying it quickly in emergency situations. It falls under hazard class 5.1, meaning it is an oxidizer. Oxidizers can support combustion and make fires more intense, so handling them with care is essential. The NFPA ratings provide a quick snapshot of the risks involved. This material has a health rating of 3, indicating that exposure could cause serious or permanent injury. Its flammability rating is 0, meaning it's not flammable under normal conditions, and its reactivity is rated 2, which suggests it can react with certain substances and needs to be stored properly. An important point to note is that this substance decomposes exothermically. That is, it releases heat when heated to temperatures between 40 and 60 degrees Celsius. This means that if it's exposed to heat within this range, it could start breaking down and generating heat, potentially leading to dangerous situations. Understanding these points helps us grasp the fire hazard classification of this material. It's crucial for safe handling, storage, and response planning, especially considering its oxidizing properties and thermal stability. Remember, always follow safety protocols when working with or near substances like this. Let's take a closer look at the hazard ratings in this table. On the left, we have the rating scale from 0 to 4, and on the right, the corresponding meaning for each level. Starting with 0, this indicates no hazard at all. These are materials that are considered normal and don't pose any risk. Moving up to 1, we see slight hazards. These materials might cause minor irritation or a small injury if you're exposed to them, but generally they're not very dangerous. At level 2, we enter moderate hazard territory. Here, exposure, especially if it's intense or sustained, could cause temporary incapacitation or residual injury. So it's more serious and requires caution. Level 3 is a serious hazard. Short exposure to these materials could result in serious temporary issues or residual injuries. For example, calcium hypochlorite is a good example of a material in this category. Finally, at level 4, we have severe hazards. Even very brief exposure could cause death or serious injury, even if you get prompt medical treatment. This table is part of understanding the blue diamond, our health hazard symbol, so it's vital to recognize what each level means to ensure safety in handling these materials. Let's take a closer look at the flammability hazard, which is indicated by the red diamond symbol. This rating system helps us understand how easily a chemical can catch fire. The ratings range from 0 to 4, with 0 meaning it won't burn even when exposed to heat or flame. Moving up, a rating of 1 means the substance must be preheated to burn, which corresponds to a flash point above 93 degrees Celsius or 200 degrees Fahrenheit. A rating of 2 indicates that the chemical needs to be moderately heated or exposed to high ambient temperatures, with a flash point between 38 and 93 degrees Celsius. When we see a 3, It means the substance can ignite under most ambient conditions because its flash point is below 38 degrees Celsius. Finally, a rating of 4 signifies an extremely flammable substance, like gasoline or acetylene, which vaporizes quickly and ignites readily. Recognizing these ratings is crucial for safety because they tell us how volatile and dangerous a chemical is and help us handle it appropriately. Understanding this scale is a key part of managing chemical hazards effectively and ensuring safety in our work environment. Let's take a closer look at this table, which helps us understand the reactivity hazard ratings represented by the yellow diamond. Starting with a rating of 0, this indicates a substance that is stable and remains even when exposed to fire or other severe conditions. Moving up to a 1, we see that some materials become unstable only at elevated temperatures or pressures, so they're more sensitive but not immediately dangerous. At a rating of 2, we enter a zone where a chemical change could happen quite readily if heat, pressure, or water are involved. For example, calcium hypochlorite, which can react under certain conditions. Now, when we reach a 3, we're talking about materials that may detonate or react explosively if triggered by strong initiating conditions. Think of substances that require a significant but not extreme nudge to cause a reaction. Finally, at the highest level, 4, we have substances that readily detonate or explode under normal conditions, like nitroglycerin. These are the most dangerous, and handling them requires the utmost caution. This table is crucial because it helps us quickly assess the potential reactivity hazard of a chemical, which ties directly into our overall goal of safe handling and storage. It's all about understanding the level of risk involved and taking appropriate precautions to prevent accidents. All right, let's talk about the special hazards, which are indicated by the white diamond on the label. These symbols are really important because they quickly communicate the specific risks associated with a chemical. For example, you might see OX, which stands for oxidizer. These substances can cause or enhance combustion. Then there's acid, meaning the chemical is an acid and can be corrosive or cause burns. ALK indicates an alkali, which are also corrosive and can be very reactive. Cor stands for corrosive, warning us that the substance can damage skin, eyes, or other materials. You might also notice a strike-through, which shows that the chemical reacts dangerously with water, so mixing it with water could be hazardous. And finally, the radiation symbol indicates that the substance is radioactive, posing radiation hazards. Understanding these symbols helps us identify the nature of the hazard quickly, which is key for safe handling and emergency response. Remember, these symbols are part of the overall system to ensure safety and proper management of hazardous materials. So, always pay attention to them. They're your quick guide to understanding the risks involved. When calcium hypochlorite is added to water, it dissolves and reacts through a process called hydrolysis. This reaction produces 2 key substances, hypochlorous acid, or HCl, and calcium hydroxide, Ka-O2. The chemical equation for this is CaClO2 plus 2 water molecules, which yields Ka-O2 and 2 molecules of HCl. Now, here's the important part. HCl is actually the active disinfectant in this mixture. That's what does the work to kill bacteria and viruses. At the same time, because calcium hydroxide forms, the solution becomes more alkaline or basic. This shift towards a higher pH is a direct result of the calcium hydroxide. Understanding this hydrolysis reaction helps us see why calcium hypochlorite is so effective as a disinfectant, because it releases HCl when dissolved, which is potent against microbes, while the solution's alkalinity influences its stability and reactivity. This reaction is a fundamental step in how calcium hypochlorite functions in water treatment processes. All right, now let's look at where the real danger can come from when dealing with hypochlorous acid. The key point here is that HCl is actually quite unstable. That means it can break down further under certain conditions. For example, if you heat it up, expose it to light, or if it comes into contact with metals or organic materials, it becomes more likely to decompose. When it does break down, it undergoes a chemical reaction where 2 molecules of hypochlorous acid produce two molecules of hydrochloric acid and release oxygen gas. This reaction is important because the released oxygen can support combustion, making fires more likely or harder to control. So, understanding these conditions helps us handle Hockle safely and be aware of its potential risks, especially in scenarios where heat, light, or reactive materials are present. This ties back to the overall theme of safety and proper handling of chemical disinfectants. When dealing with bulk or confined storage of calcium hypochlorite, it's important to understand that heat can build up quite easily. If water accidentally gets into a drum of calcium hypochlorite, a reaction occurs that can be quite dangerous. This reaction is exothermic, meaning it releases heat, and it also produces gases like oxygen and chlorine. This buildup of heat and gas can cause pressure inside the drum to increase, which might lead to rupture or even fire if there are flammable materials nearby. So, proper handling and storage are essential to prevent these risks. Another key point is the decomposition of hypochlorous acid, or Hockle, which can happen under certain conditions such as exposure to heat, acids, or contamination. When this decomposition occurs, it produces chlorine gas and other toxic byproducts. The chemical reaction shows that two molecules of Hockle break down into a molecule of chlorine gas and hydrogen peroxide. Chlorine gas is very toxic, dangerous to the lungs, skin, and eyes. Plus, it's a strong oxidizer, which means it can speed up fires if they occur nearby. So, understanding these reactions and risks is crucial for safe handling of calcium hypochlorite in storage. When heated, especially above the temperature range of 40 to 60 degrees Celsius, calcium hypochlorite begins to decompose. This process is exothermic, meaning it releases heat as it happens. During decomposition, it releases oxygen, chlorine, and other gases. This reaction is significant because it can increase the risk of fire or explosion if not properly managed. Understanding this decomposition behavior is crucial for safe storage and handling, especially since heating can accelerate the breakdown. It ties into our overall theme of safety and proper management of chemical materials in various environments. Let's take a look at the reference standards and guidelines for storing calcium hypochlorite safely. According to the UN recommendations on the transport of dangerous goods, it's essential to store this chemical in well-ventilated, cool, and dry conditions. Protecting it from heat, sunlight, and moisture helps prevent any unwanted reactions. NIOSH and OSHA also emphasize that calcium hypochlorite should be kept in areas where the temperature stays below 30 degrees Celsius. Once you go above that, especially in commercial-grade materials that are over 65% purity, decomposition can start to occur. This decomposition can release chlorine gas, which is hazardous. The manufacturer safety data sheets, or MSDS, typically advise storing calcium hypochlorite below 30 degrees Celsius. They warn against exceeding 35 to 40 degrees because higher temperatures can lead to decomposition and the release of dangerous chlorine gas. So the key takeaway here is that the recommended safe storage temperature is below 30 degrees Celsius, which is about 86 degrees Fahrenheit. The ideal range is actually between 20 and 25 degrees Celsius, or roughly 68 to 77 degrees Fahrenheit. And under no circumstances should the temperature ever exceed 35 degrees Celsius. By following these guidelines, we help ensure the safety of personnel and prevent any hazardous incidents related to storage. Keeping these standards in mind is critical as we manage and handle calcium hypochlorite responsibly. Let's take a closer look at the summary table and why this temperature information is so crucial. When the temperature exceeds 30 to 35 degrees Celsius, especially in humid or poorly ventilated areas, calcium hypochlorite can become quite unstable. It may decompose slowly and release chlorine gas, which is hazardous to inhale. Additionally, it can generate heat on its own, potentially leading to a thermal runaway reaction, meaning the heat builds up faster than it can dissipate, increasing the risk of an explosion or fire. Another key point is that higher temperatures can accelerate the oxidation of nearby materials, significantly raising the fire risk. Now, looking at the table, we see that below 25 degrees C, calcium hypochlorite is very safe to handle. Between 25 and 30 degrees C, it's acceptable but requires careful monitoring. Once we hit the 30 to 35 degrees C range, we enter a risk zone where cooling measures are essential to prevent dangerous reactions. And above 35 degrees C, it's considered dangerous. There's a real risk of decomposition, which we must absolutely avoid. So, understanding and controlling the temperature is vital to maintaining safety and preventing accidents with calcium hypochlorite. Let's go over some important safety tips. First, never mix calcium hypochlorite with fuels, oils, paper, or any organic solvents. These combinations can be very dangerous. Always store calcium hypochlorite away from any combustible materials to prevent fire hazards. It's best to keep it in a cool, dry, and well-ventilated area, ideally below 30 degrees Celsius to minimize the risk of decomposition or reaction. When handling this chemical, use non-metallic tools that are clean and dry to avoid unwanted reactions. Now, moving on to the hazards of reactions with organics. When calcium hypochlorite reacts with organic materials, it can generate a lot of heat, which can ignite the organic substance, so fire is a real risk here. The reaction can also cause explosions because of rapid gas release and heat buildup, especially in confined spaces. Additionally, toxic gases like chlorinated organic compounds and chlorine gas may be produced, posing inhalation hazards. And even if the mixture is dry, it can spontaneously ignite, which is something we must always be cautious about. To give a concrete example, when calcium hypochlorite reacts with acetic acid, a simple organic compound, it produces chlorinated volatile organics, heat, and other byproducts. This reaction demonstrates how dangerous these interactions can be, especially since it releases chlorinated compounds and heat. In general, when calcium hypochlorite reacts with organic substances such as oils, greases, paper, wood dust, or organic solvents, it oxidizes them. This oxidation process results in oxidized products, heat, and chlorinated compounds, highlighting the importance of careful handling and storage to prevent accidental reactions and hazards. Let's take a closer look at some common causes of fire and decomposition. First, contact with moisture or water can be a major issue. When certain materials get wet, they can become unstable or even react violently. Next, mixing these materials with organics, acids, or ammonia can trigger dangerous chemical reactions that may lead to fires or decomposition. Elevated temperatures are also a big concern. Heat can accelerate decomposition processes or ignite substances if they're not properly managed. Lastly, contaminated handling is a key factor. Improper handling or storage can introduce contaminants that increase the risk of fire or breakdown. Understanding these causes helps us better prevent incidents and keep our environment safe. Let's talk about some key fire prevention techniques that can make a big difference. First up is starving. This means removing or limiting the fuel that a fire needs to burn. By controlling what's flammable and keeping combustible materials away from potential ignition sources, we can effectively starve a fire of its fuel. Next is cooling. This involves reducing the temperature of combustible materials to prevent ignition. Using water or other fire-resistant agents to cool down hot surfaces is a common and effective method to stop a fire from starting or spreading. Then we have blanketing. This technique is about covering a fire with a substance like foam or fire-resistant blankets that cut off the oxygen supply. Since fire needs oxygen to survive, blocking it can smother the flames quickly. All these techniques, starving, cooling, and blanketing, are essential components of a comprehensive fire prevention strategy. They connect to the overall theme of safety by showing how understanding fire behavior allows us to intervene effectively and prevent disasters before they happen. Let's talk about some essential fire prevention measures for storage. First, it's really important to keep your materials in cool, dry, and well-ventilated storage areas. This helps prevent any buildup of heat or moisture that could potentially lead to fires. Next, always avoid exposing your stored items to heat sources or direct sunlight, as these can increase the risk of ignition. When choosing containers, opt for non-combustible materials to reduce fire hazards. Additionally, make sure to keep combustible materials away from acids and organic substances, which can be reactive and increase the risk of fires or explosions. Overall, these precautions are crucial to maintaining a safe environment and preventing fire incidents. Remember, proper storage is a key part of your overall fire safety strategy. When handling potentially flammable or explosive materials, it's crucial to use non-sparking tools. These tools are designed to prevent sparks that could ignite a hazardous environment. Additionally, it's important to avoid impact or friction during handling, as these actions can generate sparks or heat that might lead to a fire. Always wear the appropriate personal protective equipment, such as goggles to protect your eyes, gloves to safeguard your hands, and aprons to shield your body. These measures help prevent injuries and reduce the risk of accidents. Furthermore, no smoking or open flames should be permitted in the area. Even a small spark from a cigarette or an open flame can cause a serious fire. By following these fire prevention measures during handling, we significantly reduce the risk of fires and ensure a safer working environment for everyone. When it comes to safe storage practices, one of the key points is to segregate different types of materials. So, make sure to keep fuels, acids, and other hazardous substances separated from each other to prevent any accidental reactions. Another important aspect is stacking. It's best to stack no more than 2 drums high. This helps reduce the risk of falling or collapsing, which can cause spills or injuries. Temperature control is also crucial. Keep storage areas below 30 degrees Celsius to prevent the materials from degrading or becoming more volatile, which could lead to dangerous situations. Finally, always use alarms and proper ventilation systems. Alarms can alert you to any leaks or issues early on, and good ventilation helps disperse fumes, keeping the environment safer for everyone. By following these practices, we're making sure that hazardous materials are stored responsibly, minimizing risks, and maintaining a safer workplace overall. Now, let's talk about the temperature sensitivity of this material. It starts to decompose at around 40 to 60 degrees Celsius, which means that if it gets too hot, it can break down and potentially become dangerous. This is especially important to consider in environments where the temperature might rise unexpectedly. There's also a significant risk if the material gets wet or is stored in a confined space. Moisture can accelerate deterioration, and confined spaces can trap heat, increasing the risk of decomposition. To manage these risks, it's crucial to use proper thermal insulation. Insulating the material helps keep its temperature stable and prevents it from reaching that critical decomposition range. Finally, continuous temperature monitoring is essential. Keeping an eye on the temperature ensures that you can take action before the material becomes unsafe. By understanding and controlling these factors, we can significantly reduce the hazards associated with temperature sensitivity. All right, let's talk about what to do in case of a fire emergency. First, it's crucial to evacuate the area promptly and alert the team so everyone is aware and can respond quickly. When it comes to extinguishing the fire, do not use CO2 or dry chemical extinguishers, as they may not be suitable for certain types of fires or could even be dangerous in some situations. Instead, the preferred method is to use water spray or a deluge system, which can effectively cool and suppress the fire. For firefighters responding to the scene, it's essential they wear SCBA, which stands for self-contained breathing apparatus, and full personal protective equipment. This gear helps ensure their safety while working in potentially hazardous, smoky, or toxic environments. Remember, having a clear, coordinated response plan is vital to minimizing damage and keeping everyone safe. This slide emphasizes the importance of choosing the right extinguishing method and proper gear, which are key components of our overall fire emergency response plan. When it comes to small spills, the first step is to isolate the area to prevent the spread of any hazardous material. Once isolated, carefully sweep up the spill, making sure to avoid creating dust or aerosols that could be inhaled. It's important to remember that we should avoid using water unless you are specifically trained in its safe application, as water can sometimes react with certain substances and make the situation worse. Now, if we're dealing with decomposition, the key is to ventilate the area thoroughly. Good airflow helps disperse any harmful gases. If you're trained and it's safe to do so, you can also cool the area with misting, which helps slow down the decomposition process and reduce the release of dangerous vapors. Overall, managing spills and decomposition carefully is crucial to maintaining safety and protecting everyone around us. Always follow proper procedures and use your training as a guide. Let's talk about some key strategies to keep safety top of mind through training and awareness. First, scheduling monthly drills is crucial. These drills help us stay prepared and ensure everyone knows what to do in an emergency. Next, it's important to regularly display emergency contacts in visible areas so that in a crisis, help is always within reach. Access to material safety data sheets, or MSDS, is another vital point. Everyone should know how to access these documents and understand how to use them. Training here is essential to handle chemicals safely. Finally, regular inspection of equipment is a must. Routine checks help us catch potential issues early, preventing accidents before they happen. All of these elements, drills, contacts, MSDS, inspections, tie into our broader goal of creating a safety-conscious culture. Staying aware and prepared is how we protect ourselves and each other every day. Let's now discuss some of the key regulatory and legal requirements that are essential for our operations. First, compliance with the Factories Act is crucial. This ensures we adhere to safety standards, worker welfare, and operational efficiency. Next, we need to follow OSHA and MSDS guidelines, which are vital for maintaining a safe working environment and proper handling of hazardous materials. It's also important to stay aligned with CPCB and SPCB norms, as these govern our environmental responsibilities, helping us minimize pollution and protect the environment. Additionally, maintaining proper fire NOC and HAZCHEM signs is essential for safety preparedness and quick response in case of emergencies. All these aspects are interconnected and form the backbone of our legal compliance, supporting the overall safety, environmental, and operational integrity of our facility. Now, let's look at some real-life incidents through a few case studies. I'll walk you through 2 to 3 incident summaries to give you a clear picture of what actually happens in these scenarios. As we review each case, we'll analyze the root causes behind these incidents. What exactly led to the problem, whether it was a process failure, human error, or systemic issue. Understanding these root causes is crucial because it helps us identify how to prevent similar incidents in the future. Finally, we'll discuss the lessons learned from each case. These lessons are practical insights that can be applied to improve safety, efficiency, and overall risk management in our operations. By examining these real-world examples, we reinforce the importance of proactive analysis and continuous improvement, which ties back to our overall goal of fostering a safer and more reliable work environment. Let's take a look at some key areas in our audit checklist snapshot. First, is the storage temperature monitored? It's essential to regularly check and record storage conditions to ensure product safety and quality. Next, are there signs of moisture? Moisture can lead to contamination or spoilage, so spotting any signs early helps us maintain a safe environment. Then, do we have emergency equipment readily available? Having the right tools on hand, like fire extinguishers or spill kits, is crucial for quick response in case of an incident. Lastly, are staff trained? Consistent training ensures everyone knows how to handle equipment, follow procedures, and respond effectively in emergencies. Overall, these points highlight the importance of proactive monitoring and preparedness in maintaining high standards and ensuring safety across all operations. Let's wrap up with some key safety points. First, remember that this substance is a strong oxidizer, so handle it with care at all times. Next, it's crucial to keep it segregated from incompatible materials and maintain proper temperature controls to prevent any reactions. Water should only be used for firefighting purposes, never to try to extinguish a spill or fire involving this material unless specifically advised. Lastly, regular training is essential for everyone involved. It keeps safety protocols fresh in our minds and ensures we're prepared for any situation. These points are vital to maintaining a safe environment and preventing accidents. Keep these in mind as we continue to prioritize safety in all our operations. Let's take a closer look at the detailed extract from the MSDS for calcium hypochlorite. This chemical contains about 69% active chlorine, which makes it a potent disinfectant but also a hazardous substance. In terms of hazard classification, it's an oxidizer, meaning it can intensify fires if it comes into contact with combustible materials. It's also corrosive to the skin and eyes, and it poses acute toxicity risks if ingested or inhaled. Additionally, it is very toxic to aquatic life, so environmental precautions are crucial. The signal word for this chemical is warning danger, which indicates that it poses serious hazards. The major hazards include its ability to intensify fires and its corrosive nature, which can cause severe burns to skin and eyes. It's toxic if swallowed or inhaled, so handling requires caution. For firefighting, only large amounts of water should be used to extinguish fires involving calcium hypochlorite. Do not attempt to use CO2, dry powder, or foam, as these are ineffective or potentially dangerous in this context. When it comes to incompatible materials, avoid contact with acids because they release chlorine gas, which is highly toxic. Also keep it away from organic materials, ammonia, and reducing agents to prevent dangerous reactions. In case of eye contact, rinse immediately and thoroughly with water for at least 15 minutes and seek medical attention without delay. For skin exposure, remove contaminated clothing and rinse the area thoroughly with water. If inhaled, move the person to fresh air and monitor their breathing closely. In case of ingestion, rinse the mouth, do not induce vomiting, and seek medical help immediately. Storage conditions are equally important. Store calcium hypochlorite in a cool, dry, ventilated area, ideally in high-density polyethylene containers, and keep the temperature below 30 degrees C to prevent decomposition or reactions. Environmental impact is significant. This chemical is very toxic to aquatic life, so it must be handled carefully to prevent any release into drains or water bodies, which could cause severe environmental damage. Lastly, always wear appropriate PPE when handling this chemical. This includes gloves, goggles or a face shield, a chemical suit, and a mask if dust is present. Proper protective equipment is essential to ensure safety during handling and accidental exposure. By understanding these key points, we can manage calcium hypochlorite safely and responsibly, minimizing risks to ourselves and the environment. Thank you so much for your time and attention today. I really appreciate you being here and engaging with the material. Remember, the key takeaways are what we've discussed about the importance of innovation, collaboration, and strategic planning in achieving success. I hope this presentation has provided you with valuable insights and practical ideas that you can apply moving forward. Again, thank you for your interest and participation. I look forward to seeing how you implement these concepts in your own work.